Welcome to The Explainer. Today, we're going to unpack a set of programming rules that are, believe it or not, from 1989. And yet, they might just be the secret weapon modern developers need, a powerful antidote to all the complex, tangled code that slows us all down.
So have you ever felt like you're just trapped, in a constant battle against software complexity with mysterious performance bugs popping up out of nowhere and staring at code that you wrote a month ago and have no idea what it does? Yeah, you're definitely not alone. It's a struggle every single one of us faces.
While the programmer who offered a way out of this mess is Pike. And when I say he's a giant in the field, I mean it. This is a guy from the original Unix team at Bell Labs. He co-invented the Go programming language and even UTF-8. He basically took decades of hard-won experience and boiled it all down into 5 deceptively simple rules.
All right, here's our game plan. We'll kick things off with the core problem we all face as programmers. Then, we're going to break down Pike's philosophy into 3 key parts. And finally, we'll talk about why these rules matter more than ever, especially in the age of AI.
Okay, before we can really appreciate the solution, we have to get crystal clear on the problem these rules were designed for. And really, it's all about fighting our own worst instincts as developers. So here they are, the 5 rules at a glance. But I want you to think of these not as just 5 individual tips, but as a unified guide. It's a whole philosophy, really, designed to steer us away from those common pitfalls of over-engineering and pure guesswork that lead to brittle, complicated software.
The first part of Pike's philosophy is a direct assault on one of the most seductive, time-wasting traps in all of programming, trying to make things fast before we even know if they're slow.
Pike's first 2 rules are really a powerful spin on this famous maxim from computer scientist Tony Hoare. It's a warning that has echoed through the decades for a very good reason. Our intuition about where a program spends its time is almost always wrong.
This really shows the 2 paths you can take. On the left is the guessing game. We've all played it, right? We throw in Redis or some caching layer because it feels like the right move. But on the right, you have the measurement method. This is where you use a profiler, you find the actual bottleneck, and you focus your energy there. The difference can save you days or even weeks of wasted effort.
Let's move on to the next couple of rules. These ones champion the incredible power of just keeping things straightforward, even when our instincts are screaming at us to get clever. Pike's colleague, the co-creator of Unix, Ken Thompson, pretty much rephrased rules 3 and 4 with this brilliantly pragmatic advice. It's not about being lazy. It's about choosing the most direct, understandable, and reliable path to a solution first.
So here's the crucial point, that theoretically fastest algorithm you learned in school isn't always the fastest in practice. A lot of those fancy algorithms have a high startup cost, a big constant factor that makes them slower for the small data sets we deal with 99% of the time. Simple, clear code is almost always less buggy and way easier to maintain.
And this table just breaks down that trade-off perfectly. A developer on Hacker News gave this great rule of thumb. If your dataset has a few hundred items, and it's almost never going to go over 1,000, the simple n-squared solution is almost always a better choice than some complex n log n algorithm. And that brings us to the 5th and final rule. And this is not just another tip on the list. This is the foundational principle. This is the absolute core of the entire philosophy that makes all the other rules click into place.
This is it. This is the heart of the matter. Before you write a single line of code for an algorithm, before you even think about loops or logic, you have to focus on your data. Get the data structures right, and the code will practically write itself.
And it's not just Pike. Another legend, Fred Brooks, made the exact same point in his classic book, The Mythical Man-Month. This tells you it's not just an opinion, it's a fundamental principle of software engineering. Your data models are your program's destiny.
Just think about this story from a developer on Hacker News. A student spent days, literally days, writing thousands of lines of fragile code because they chose the wrong data structure from the start. A single moment of clarity, just 20 minutes to rethink the data and use a tree instead, would have turned that nightmare into a simple 50-line solution. That is Rule 5 in action.
So what happens when we put all these pieces together? Well, we get more than just a set of rules. We get a cohesive strategy for building better software.
So you can see, these aren't just 5 random tips. They form this interconnected philosophy for writing better software, a philosophy that's inherited directly from the giants who built the very foundations of modern computing.
Ultimately, this philosophy isn't just about some kind of technical purity. It's about reducing real-world risk. Teams that live by these principles, they onboard new engineers faster, they make changes more safely, and they deliver value to their users more quickly.
And that leaves us with one final crucial thought for right now. In an age where AI can generate complex algorithms in a matter of seconds, does the uniquely human skill of designing clear, simple, and elegant data structures become the most valuable thing a programmer can do? That's definitely something to think about.